Welcome to section 1.4, part 2. This is where we're going to go through dividing and making mixed numbers and proper and improper fractions mixed numbers. So the first thing, we kind of already talked about it previously in part 1, adding the fractions in a different way than what was addressed in the previous or in your book. I'm going to come back here actually and just quickly do this one the way the book showed you, which was a little less complicated. You don't have to make it the improper fraction. You can if you would like. What we did here is multiply the top and bottom by 3, and you can keep the 7 out front and keep that and keep the 4 with the 2/15, and instead of making these improper fractions, you can just add them. I know this should be in part 1, and it's a little less complicated that way. So to make this least common denominator was 15, so we only needed to work on the left hand side. So we have 7 and 3/15, and we're adding 4 and 2/15. We can just add these together, which makes 5/15. 2 plus 3 is 5, and the 4 and the 7 we can add together, which makes 11. And then just simplifying 5/15, divide the top and the bottom by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3, which is 11 and 1/3. So I apologize. I made that one a little more complicated because you don't have to change it from its mixed number to the improper. But we did go through a little bit of changing mixed to improper, which is the clockwise circle, and we multiply and add. So here we start at 6. 6 times 3 is 18. And if you need to keep a running total off to the side, go ahead. And then we add 1, which makes that 19. And you keep the denominator, which is 6. So it's 19/6. All right, let's try the next one. And go ahead and keep your scratch work on your paper. Mine's just to keep things clean. 5 and 3/4. Again, the clockwise circle starting at the bottom. 4 times 5 is 20, and if you want to keep track of it like this, you can as well. Plus, remember times here, plus here, add the 3, which makes 23. So this is 23 over, keep the denominator, which is 4, and our sign is negative. So it's negative 23/4, or 23/4. Okay, the next one is going backwards from improper to mixed. In this one, you actually have to divide a little bit. So we're going to take the top number, 56, like we did in the previous section, divide it by 9. 9 goes into 56 how many full times? 9 times 6 is 54. Subtracting gives me 2 left over, so we have a remainder of 2. What we did in the previous section with decimals is we did the decimal and brought down zeros. For this one, we want the remainder because that will help us know what the fraction is. Now we talked 9 goes into 56 how many whole times? 6 whole times. So that's the big whole number out front for the mixed number. Now I have 2 of these portions left, so it's 2, and the denominator always stays the same, so it's 9. So 6 and 2/9. And that's how you change it from the improper to the mixed number. Okay, let's move on to the next example. This is where we start dividing fractions. These ones you do not need a common denominator. So what we do need is to multiply by the reciprocal or the multiplicative inverse, which you kind of went through a little bit in your book. What I like to do is I imagine that as I'm flipping this second fraction, that it kind of twists that division sign so it looks kind of like an X because you're twisting just one side. Do not touch the front fraction. It always stays the same. That 3/8, leave it. It's off limits. The first one stays there. But as I twist the second one, it becomes a multiplication sign, and this becomes the reciprocal 4/9. And now to multiply, I can multiply straight across and simplify, or I can simplify first and then multiply. It's up to you. Either way works. My personal preference is to simplify first and then multiply because then I work with smaller numbers. To simplify first, I can simplify any numerator with any denominator. So 3 and 9. I can simplify by dividing both of these by 3. And what I do for just me is I cross out the 3. 3 divided by 3 is 1. So I put what I am left with when I divide it by the number that goes into both of these. 9 divided by the same 3 gives me 3, and I write it just kind of a little off to the side. Then I'm looking over here. 8 and 4 will also reduce. Now remember, I can use any numerator with any denominator to reduce or simplify. 4 and 8 are both divisible by 4. So this right here says I'm dividing it by this common number, and you just have to remember that in your head that you are dividing it by 4. 4 divided by 4 is 1. So now this new number up here is a 1, no longer a 4. 8 is also simplified. I have to divide it by the exact same thing that I am simplifying this top one by, which was 4, and that leaves me with 2. So now this is really, notice how I've crossed the 4, the 3, the 8, and the 9 out. This is really the problem 1 over 2, because that's what I have leftovers, and 1 and 3 times 1 and 3. Now in multiplication, which is different than addition, you multiply the numerators and you multiply the denominators. So in this one, you actually change the denominator. 1 times 1 is 1. 2 times 3 is 6. So that's the method of simplifying it before you multiply. If you would prefer, and I'm just going to go ahead and erase this, if you would prefer to multiply and then simplify because you feel that that's easier, it's completely up to you. I'm going to go ahead and do that method as well. So again, keep the first number. He's off limits. Do not flip him. But as you're twisting this second one into a 4/9, it twists that division sign into a multiplication, and so we have 3/8 times 4/9. So this method, you just multiply straight across. The numerator times the numerator straight across. 3, right here, 3 times 4 makes 12. Okay, and then down here we have 8 times 9. 8 times 9 is 72. And you just have to look at 12 and 72 and see if something will go into both of those that will simplify. And you can start off small, saying, hey, both of those are even, and divide them by 2. You could say, I think maybe a little higher number like 4 will go into those, and divide them both by 4. It's up to you either way, but I do know that these are both divisible by 12. And some of you are thinking, yeah, the multiplication monster for uh, section, I think it was 1.1, um, you already had that memorized so that you know that 12 times 6 is going to be 72. So, whoops. So 72 divided by 12 gives you 6. 12 divided by 12 is 1, and you've now simplified it. This method, you have larger numbers, and it's up to you if you would like to use it. That's fine. I prefer simplifying beforehand, though. Okay, so the next one I have 2 and 3/7 divided by 34/21. The first thing I need to do here is make my first fraction into an improper fraction instead of the mixed number. So we're going to do our clockwise circle, multiply and add. So I have 7 times 2. If you need to keep a little note of our running total, that's 14 plus 3 makes 17. Keep the denominator, 17/7. Now I need to multiply this by this reciprocal, or I flip it to get 21 over 34. Okay, so we could go ahead and multiply this one, 17 times 21, and 7 times 34. But again, we have very large numbers when we do that, and I would rather save myself a little bit of the headache and hassle and simplify beforehand. And I can simplify any numerator, the 17 or the 21, with any denominator, 7 or 34. And whatever you do to the top, you must also do to the bottom. So I know 21 is divisible by 7. So I'm going to pick this numerator and this denominator and reduce them by 7. So 21 divided by 7 is 3. And 7 divided by 7 is 1. So now I have reduced this, and that saves me in the end from dividing by a 7. I also know 17 and 34. That looks like 17 times 2. There's two 17s there, so I can divide these both by 17. This top part, 17 divided by 7 is 1, and the bottom, 34 divided by 17 is 2, which is great. Now some of you will like to rewrite this since it looks kind of messy. Others will say, I don't need to rewrite it. I have all the numbers there. I've crossed out the ones that I'm not using, so I'm left with a 1. 1 times 3. And that's the numerator. The bottom down here, the 7 is gone. I've crossed it out, so I'm left with the 1. 1 times 2 is 2. And there we go. 3/2 is the answer, which is a lot faster than trying to multiply 17 times 21. It's just my preferred method. But wait, 3 over 2 is an improper fraction, so I would like to change that to its mixed number. To do that, you take the top number and divide it by the bottom, or the numerator divided by the denominator. 2 goes into 3 one whole time. 1 times 2 is 2. Subtract is 1. So it's 1 with a remainder of 1. That means 1 whole time and 1 over 2 for the remainder. And that one's kind of nice. Some of you are thinking, I can think of 3/2 as being 1.5. And that one, you don't have to go through the long division if you can do that one in your head. It's up to you. All right, let's move to number 13. Number 13 starts out as this huge fraction, 5 over 8 over 3 over 16. This is called a complex fraction, and I don't like those. So what I'm going to do is take this division sign in the middle and write it out as a division sign like this. So I have 5/8 divided by 3/16, and I like that method better than seeing the large compound fraction. Okay, so the first thing we need to do is set it up. 5/8, we never divide fractions, we always multiply and do the reciprocal for the second one. And my method is to simplify beforehand. So I look at all the numerators, 5 and 16, with all the denominators, 8 and 3, and I notice that 16 and 8 can reduce. Both of these are divisible by 8. So I'm going to go ahead and divide 16 by 8, which leaves me 2. 8 divided by 8 is 1. And then it looks like that's all I can do here. So now I can just multiply straight across, and just because that kind of snuck down a little bit, get rid of that so I can multiply. 5 did not cancel out, so I have to keep it. 5 times, what's left here is 2. That gives me 10. And then down on the bottom I have 1. That's left. Times 3. So I get 10 over 3. And that's my improper fraction. To change it to its mixed number, we can divide, which would be, let's give myself some room, 10 divided by 3. 3 goes into 10 3 whole times. 3 times 3 is 9. Subtract is 1. So we have a remainder of 1, which when we write it, it went in 3 whole times, so it's 3, and 1 remainder over the denominator, which stays the same, of 3, which is 3 and 1/3. There we go. Let's move to the next example. And I'm actually going to come over here and just give myself some room. How's that? Oh, nope. Can't give myself some room. We have more problems down below, so I apologize. We're going to have to erase again. Just erase some of this so that I have some room to do some scratch work. All right, so let's go ahead and move to the next one. 5/18 divided by 3/4. Again, we keep this very first number, 5/18. It stays the same. But the second number, multiply by the reciprocal, which is 4/3, and see if I can reduce beforehand because it makes it nicer. Okay, so 5, it doesn't look like it reduces with any of the denominators. It doesn't go into 18, nothing goes into 3 with the 5, so that one, it stays. Let's come check out the 4. 4 and 18, ooh, those are both even numbers, so I know both of those can be divided by 2. So let's go ahead and simplify that. 4 divided by 2 is 2. 18 divided by 2 is 9. Okay, it looks like that's all that simplifies. So 5 times, what's left here is 2 because we already simplified, which gives me 10. And then on the bottom, 9 times 3 is 27. And I look at this because I simplified beforehand. This is as simplified as it will be, and the answer is 10/27. Okay, let's move to the last example of this, dividing fractions. The first thing I need to do here is change my mixed number into an improper fraction. So we're going to do our trick of the clockwise circle, and starting here, 25 times 2 is 50, and if you need to write that down, go ahead. 50 plus 6 is 56. So that fraction right there is 56/25. And it's still 8/15 divided by 56/25. Okay, but remember, we don't divide fractions, we multiply by the reciprocal. So this is 8/15 times 25 56th. Okay, now we could go ahead and multiply 8/25ths over and 15 times 56, but again, like I said, that gets really kind of big numbers, so I like to simplify. And I noticed 8 and 56 are both divisible by something. Do you know what it is? That's right, 8. So I'm going to divide this by 8, which makes 1. 56 divided by 8 is 7. And again, I have something else. 25 and 15 are also both. Something goes into both of those. 5. 25 divided by 5 is 5. 15 divided by 5 is 3. Now I've crossed out the 8, 25, 56, and 15. So I'm only left with 1 times 5, which is 5. And for the denominator, 3 times 7, which is 21. And the answer is 5 over 21. There we go. And because we simplified beforehand, we have much smaller numbers, and that's as reduced as it'll get. Okay, let's move on to problem number 16. This is changing into a decimal. I feel this is kind of a review from what we did in the previous section, but we're going to go ahead and do it one more time just for good practice. So the first thing we want to do to change this fraction into a decimal is put the numerator on the inside and the denominator on the outside. A funny way of remembering that is to think of a top hat. Why? Because you take the top number and give him a hat, which is the division sign. So if you're having a hard time remembering which one goes inside, just think of the word top hat, and the top number gets the hat, which is the division sign. Okay, I noticed 8 will not go into 5 evenly, so I need to give myself a decimal and then a 0. Now, for the answer, I need to move this decimal straight above right there. Okay, now I need to think of how many times will 8 go into 50? 8 times, oh, I know 6. 8 times 6 is 48. Subtract is 2. Okay, so now I need another 0. So I'm going to tack on another 0 and bring it down and see how many times 8 will go into 20. 8 times 2 is 16. And that's as close as I can get. So I'm going to subtract here. 20 minus 16 is 4. Okay, well, I don't want a remainder, so I'm going to keep bringing it down and give myself another 0. And bring that over. So now 8 goes into 40. Hey, that goes in evenly. 8 goes into 40 5 whole times. 5 times 8 is 40. Subtract is 0. Check. Good, we're done. And I have now changed my fraction 5/8 into the decimal, 0.625 or 625 thousandths. Okay, let's move on to the next example. And I'm going to erase just a little bit so that it doesn't run over into my number 17. Okay, number 17, this is where I change a fraction, a decimal into a fraction. This is where knowing your place values comes in very, very handy. And I'm going to bring that up right now. From a previous video lecture, we had the place values in this chart here. It's really important to know these place values after the decimal when we're changing from a decimal to a fraction. The first one is tenths, the next one's hundredths, thousandths, 10,000ths, and so on. The tenths is just like a 10, 1 0. 100 is 100, right? Okay, so let's go back into our assignment. Okay, so this one is one decimal place out. This is 6/10. Bringing out this. So we get 6 over 10 because it's 6/10. Another way of remembering that is that I only have one decimal here, that means I have 1 0. And then it's just a matter of simplifying. What will go into both 6 and 10? 2. So I'm going to divide top and bottom by 2 to simplify. 6 divided by 2 is 3. 10 divided by 2 is 5, and the answer is 3/5. There we go. Okay, let's try the next one. Here I have 3 place values out. If you remember your chart, that's 15 thousandths. Another way of remembering that is I have 1, 2, 3 place values, or 3 decimal places. So I have 15 over 1 with 3 zeros. There we go. So now I just need to find what will go into both 15 and 1000. Because it is ending with a 5 and a 0, I know 5 will go into both of those. So let's go ahead and divide these by 5. 15 divided by 5 is 3, and 1000 divided by 5, if you're having a hard time with that, you can write it out with some scratch paper. 1000 divided by 5. 5 will go into 10 2 times. That's 10, subtract a 0. 5, we bring down the next 0, goes into 0 0 times. Bring down the next 0, 5 goes into 0 0 times, which gives you 200. So it's 3 over 200. All right, our last one is 0.875. So I need to make this 875 over 1000 because I have 1, 2, 3 decimal places. Again, I have a 5 at the end and a 0, so I know both of those are divisible by 5. But I'm going to kind of think of this as money. 875, it's almost like having $8.75 in quarters, so I know that's divisible by 25. So I'm going to divide this by 25 and put this by 25, just to save us a little bit of time. Let's go ahead and 8 divided by, or sorry, I apologize, 875 divided by 25. Instead of doing that all out by hand, I'm going to go ahead and just tell you that it's 35. If you wanted to, you could have done 875 divided by 25, or you could think about it as quarters, $8.75 into quarters. And down here, 1000 divided by 25, that's kind of like saying $10 divided by quarters, and that's 40. But wait. Here I have another number ending in 5 and 0. That means both of these are still divisible by 5. 35 divided by 5 is 7. 40 divided by 5 is 8. Nothing will go into both 7 and 8, so that's as simplified as it can go. So another way that you could have done this is divide both of these by 125, but that got a little complicated, so I broke it down into what I knew would go into both of them, which was 25, and then I checked again and divided by 5. Now if you didn't see that, you could have just divided by 5 at first, or whatever you can kind of see for your mental math. You don't have to have it all done right at the beginning and divide them both by 125. Whatever works best for you. And that is the end of part 2. Good luck on your homework.